over here looking at is going to be a simple Arduino based battery charger control. This is just one of your 12.6 volt gel cells. You might use it in, say, emergency lights or another project. This is a voltmeter that's it's one of these little panel meters that's connected across the battery. It's sitting around 12.6 volts. Attached to it is the following circuits. I've got this power. This is my little power distribution bus, and this is a switching power supply. It's used to simulate a solar panel or maybe another power supply or a battery charger. The idea being to switch it on and off. This is an Arduino here. That's your Arduino. This is the switch between, this is a transistor switch between the charging power supply and the battery. And the idea is that this will charge up to a certain degree when it drops below a certain point, which it is now, which is why the LED is blinking. That's the charge light. I have not plugged in the main power supply to charge the battery, thus it's not going to charge until such time it'll charge up above a certain point, then shut down and wait around and see if it drops below a certain point, then simply kicks in again. Very simple program, very simple construction. Let's see how it works. Let's go back to our panel meter and battery. Let's zoom in on this guy a little more. Alright, I'm going to plug in the power supply. What you will see is the voltage will climb for 2 seconds, then fall back and climb for 2 seconds, then fall back. It'll climb up as it's charging on for 2 seconds, then it will go off. And sooner or later it will charge up to an off voltage, which will cease the operation of the charge circuit until it drops down below a certain point again. And in a short while it certainly will, of course. You notice that the on voltage when it goes off is becoming higher and higher. This is what it should be doing. At any rate, let's take a look at the circuit diagram and take a look at the program. Look at this schematic. I redid my schematics to the solar charger circuits, and they should be much more clear and informative than they once were. Let me walk you through this one, which is a big modification from the old one. Here, of course, it represents an Arduino Nano. Now, the code for this is generic. It should work on any Arduino out there. This is your battery under charge. Now, I'm not talking about using this thing to charge huge industrial batteries or 1,000-watt solar systems. These are for rather small things like gel cells or maybe one battery with, I don't know, maybe 40, 50 ampere hours or something like that. This is the battery under charge. Test point 2, you can put a voltmeter on it and check the voltage on the battery. Now, this Arduino Nano, it shows a VN back to the battery. If you don't have a Nano and you have which has its own built-in voltage regulator, you'll need a 5-volt regulator circuit. And of course, that connection will not be there. Out of digital pin 2 through a 2.2K resistor, I switch on this small NPN transistor Q2, which switches on Q1, which is an MJE 2955T. It has a TO220 case, handles probably 10 amps. You'll need a heatsink if you're running a lot of amps. Over here at test point 3, you can measure the voltage out of the solar panel. This is your solar panel here. If you know how these are constructed, it's a bunch of series silicon cells, and it usually has a polarity blocking diode built in. That's already there. This is obviously the positive terminal. Under a load, they will put out 12 to 15 volts, depending on the intensity of the sunlight. This is important to note here. This is a 10-volt Zener diode that runs through a 560 ohm resistor to ground. Test point 1 is going to read from 0 to 5 volts. In other words, when this switches on, well, what you're doing is you're measuring the battery voltage at test point 2. Test point 2, you're measuring the battery voltage, dropping 10 volts of the voltage through the Zener diode, leaving you 0 to 5 volts for the analog digital converter in, which is ADC0. You don't want to exceed 5 volts. That's why I got the Zener diode there. The Arduino will read the voltage, and then it will switch on Q2 and Q1 based on that voltage reading. Here's a brief view of the main program and loop. Of course, the associated web page has the full program. Most of this consists of just simply delay circuits. We're going to read analog port 0, which is VN. I commented these out. And we're going to do a while loop. It's going to look at the value returned from the analog read, and if it's greater than 600, it's just going to stay stuck in this while loop and print it out. 600 means it's, from my measurements, it's charged up. It's around 12.7, 12.8, something like that. You can fiddle with the number a little bit if you want to. But while stuck in the while loop, it's printing out these various voltage parameters. It's giving you the charge off value, which is 600 there. Well, it's 605. And it's going to give you a reading of the voltage on the battery. In this case, it's sitting around 12.9 volts with a charge value of 607. Again, an analog to digital converter in Arduino, which operates from 0 to 5 volts, returns a value from 0 through 1023 decimal number. And that's all most of this does. Now, where did I get this down here? I printed val times 0.0048 plus 10. That's what's given me the V battery equals 12.93. The way you come up with this number here, you will sit here and you will use the serial monitor to see what the val is. It will tell you. You make a voltage reading on the battery with the solar panel disconnected, so it's not switching on and off on you. With the solar panel disconnected and the battery on there, you'll read the voltage across the battery, and then you will subtract 10, and then you will divide by 606, and that's where you got this number, if that's what it comes out to be. This makes up for variations and tolerances in the resistor, Zener diodes, and so forth. Like I said, these are just delay loops down here. If it's as long as it's greater than 600, as a number I ended up with from my test, it'll just loopity-loop and print this. If it's less than 600, it will drop out of the while loop. Down here, it will cut the Q1, Q2 voltage on and let the solar panel charge your battery up. Then we have a delay value. I used 4 seconds. Then it's going to go low. Then it's going to cut the charge switch off, delay another 4 seconds. Then it's going to go back up here and read the value, the battery voltage again. And if it's still less than 600, it's going to skip the while loop and go through the sequence again until the battery charges up. Well, as the battery most of the time, the voltage values that are being used to charge this battery, most of the time the values are going to run from 12 volts to 14 volts generally, usually 13.5. And so 600 from my measurements is right somewhere in between, probably 12.7. A battery, a lead acid cell, is charged up when it's 12.6, 12.7. So be your own judge. Here is a closer look at the serial monitor on the Arduino. The serial monitor does not have to be connected for the circuit to work. This is just something to give me some troubleshooting information if I need it. All right, here's one last issue to deal with if you want to look at it. Going back to our original circuit, here's my Zener diode circuit connected to the battery through a 560 ohm resistor, and Vn at test point 1 is going to read that 12 to 14 volt voltage, which normally should be there. The problem is this circuit, unless you have a really big battery or it's pretty well charging all the time, will gradually discharge the battery. This circuit, if you decide to use it, you'll connect this to the battery, that goes to ground, and this goes on to the Arduino analog to digital converter, or test point 1 as we had before. You'll have to use another pin on the Arduino, digital pin 2 or 4 or whatever you're not using, and you just have to cut it on in the software. Is when you do a voltage reading, you switch the Arduino pin to a high. It switches this little 2N2907, this is a small silicon transistor, and switches the battery voltage to the Zener resistor combination so you can read the battery voltage. The advantage of this is when this is low and turned off, it won't drain the battery. It won't put that little drain on the battery. Now, if you've got a 100 ampere hour battery or something big, a few milliamps isn't going to make a difference. But if it's a gel cell and the sun doesn't come, it doesn't put much of a drain on it. But if that is a concern, you can use this circuit and get by that. And that completes this introduction to this updated Arduino battery charge circuit. Note that this doesn't necessarily have to be a solar panel. It could be just another power supply that you're using to charge a battery. But you're going to have to have probably 13 to 15 volts coming into TP3 before it will charge. Nonetheless, that's the video. I thank you for watching. Please visit my website at www.bristolwatch.com and click the link presented below on the YouTube page, and you can go to the web page and find out more about this and the complete Arduino program. Thanks, and have a great day.